dear students, let's see this question number 3.13 of Irodov. The question states, a thin straight rod of length 2a carrying a uniformly distributed charge q is located in vacuum. Find the magnitude of the electric field strength as a function of distance r from the rod center along the straight line A perpendicular to the rod and passing through its center. B coinciding with the rod's direction at the points lying outside the rod, and investigate the obtained expression at R much larger than A. So let's look the first part first. So this is the rod. This rod has a total charge Q and total length A, 2A. And this is the midpoint of the rod, say O. And we have to find electric field at a distance x along a direction which is perpendicular to the rod from the center. So not x, but r. So we have to find electric field at this point along the perpendicular bisector of the rod. So what I am going to do, I am going to take two little elements on both sides simultaneously. Suppose I go a little distance, some distance x from the center on this side, and also some distance x from the center on this side, and then take two elements of width dx here also and on this side also. So these two elements have width dx. The charge on these elements are, say, dq. So dq will be charge per unit length, that is a q upon total length, into the width of the element, which is dx. So because of these elements, we want to find the electric field at the required point. So because of this dq, and suppose this angle is, say, theta. So because of this dq, electric field is dE along this direction. And similarly, because of this element dq, symmetrical to this dotted line, these two elements are. So here also, the line is not so good. Let me redraw it again. So this will also be dq, dE, and by symmetry, obviously, this angle is also theta. So this angle is theta and this angle is theta. So what will happen there? Their sine theta component of both dE will cancel, and cos theta component will get added. So the resultant electric field, because of this both dE, is suppose that is a dE nut. So I can write dE nut is equal to dE cos theta, that was the component of electric field along the white dotted line because of the 1 dq, and because of the both, that will be twice of that. And I want to write this length. This length is, you can see that this length is, this is r, this is theta. So this length is r sec theta. So dE is equal to k, value of k I'll write later, k, and this t is because of the 1 dq. So k dq, and divide by square of the distance. So square of the distance from BQ to that point B is r sec theta, and square is r square sec square theta. And then there is a cos theta. So this is a cos theta here. And what we can see that we can also write, I want to write everything in terms of the angle. So you see that here x is equal to, you can see that x is equal to r uh, tan theta. So dx we can write as r sec square theta d theta. So here I can write q by 2 is already there. And in place of dx, I am writing r sec square theta d theta. So I am going to put the value of dq here. So twice k, dq is q by 2a into r sec square theta d theta, and there is a cos theta in the denominator. There is r square sec square theta. So we have got rid of sec square theta. Now some simplification, and this 2 and 2 will also get cancelled. Sorry, 2 and 2 will get cancelled. So that will be kq by 1 r will get cancelled and a is there. So kq by r into a, and cos theta d theta, and that's what we are remain with. So now what will be the E net? E net will be kq by ra cos theta d theta, and we have to put the limit. Everything I have done in terms of theta. So, and I've taken two elements together, so I don't have to take on both, only one side, because this electric field is because of these two elements. So as I take these elements from here to here, my whole rod will be covered, and the variable is theta. So suppose when this element is here, so theta is 0, and when this element comes to here, so suppose at this position, uh, this theta becomes a phi. So the limit of theta will go from 0 to phi. So limit will go from 0 to phi, and cos phi integration is sin phi, and if we'll put limit, we will get kq by ra sin phi. And now time to put the everything in final form. So that will be E net, and k is 1 upon 4 pi epsilon naught q by ra and sin phi. What is sin phi? Sin phi will be a upon this length. And how much is this length? This length is obviously r square plus a square root. So that is a square root of r square plus a square. And this a and a will get cancelled. So I can write E net here, that I got for this case is equal to q divide by 4 pi epsilon naught r into square root of r square plus a square, and it is answer to part A. And when the r is much larger than a, so what we can do here, we can neglect this a square in terms of r square. So in that case, when r is much larger than a, that e will be reduced to q upon 4 pi epsilon naught r square. And now let's see the second case. Case B. So this is the situation of case B. Again, this is a rod of length 2a, and we have to find at an axial position P, which is at a distance small r from the center. So let me take some element. I'm taking element from here. Suppose I am taking some element here. This element is at a distance x from point P, and the element has a length dx, like this. So again, charge on this element dq. This dq is again q by total length, q by 2a, this charge per unit length, into the length of the element dx. So because of this little charge dq, there will be electric field at p along this direction. And now all the elements will have the electric field on this direction, same direction. Simply net electric field will be the algebraic sum of all these dE's. So E net is simply now integration of dE. And what is dE? dE is equal to K dq divide by, let me not write this, r is another value. This is a x. So dq, this is a x, and so this is dq by x square. So put the value of everything, that k 1 over 4 pi epsilon naught, dq is q by 2a, and then there's a dx and x square. So as I take this element from here to here, this element will cover the entire rod. So when this element is here, so my x is equal to small r minus a. And when this element goes to here, the x is the distance of that element from the point P. So then x will be small r plus a. So the limit will go from r minus a to r plus a, and this is now q by 8 pi epsilon naught a. And this integration will be minus 1 by x. And if you put the limits, upper limit and lower limit, I will get 1 over r minus a minus 1 over r plus a. Some simplification. So E net will be q by 8 pi epsilon naught a, and here that will be r square minus a square, and here that will be 2a. So this a and a will get cancelled. So this will be q by 4 pi epsilon naught, and divide by r square minus a square. So this is the electric field for the axial position. And again, for the limiting case, when the r is much greater than small a, so this a square can be neglected. And for that case, E net will be q by 4 pi epsilon naught r square, and that is our answer. Thank you.